Okay guys, so as promised, I just wanted to bring you a tutorial on how to perform the upgraded or the more complicated dosage and calculations expectations that we'll have for you here in fourth semester. So I sent you guys a some practice examples, and I posted them to the Canvas shell. And in doing so, I gave you some time to try to play around with it, and then I just unlocked it so you guys can see the answers. So now I'm going to just kind of run through it for those of you that haven't done dimensional analysis for a while or never really learned dimensional analysis. I want to kind of do two ways to work this out. So one we call dimensional analysis, of course, and of course it's the game of trying to eliminate the units so we can get the desired units at the end to answer the question. And the other one is called base concentration, or reverse engineering, I kind of call it, just to kind of work through it. If you didn't know dimensional analysis, how can you answer these questions? So we'll always start with dimensional analysis. I probably won't work through all 8 questions here, but let's give it a shot, okay? Let's see how many we get through today. So number 1 states the patient is receiving nitroprusside at 23 mLs per hour. The bag has 50 milligrams of nitroprusside in 250 mLs of solution. The patient weighs 67 kilos, so right away they tell us the kilos. We don't have to work that out. And just to let you know, I'm not gonna, add that into my dimensional analysis. I might skip a few steps of the whole dimensional analysis, because I don't want to, I don't want to make it too long. If I know how to convert, pounds to kilograms, I'm going to do that and then just add that kilogram into the dimensional analysis instead of the pounds to kilograms and this many kilograms and this many pounds, etc. So the question's asking us in this time, what dosage of nitroprusside is in micrograms per kilogram per minute is the patient receiving? So as I mentioned before, this is basically the black belt of dosage and calculations. They want you to basically say, you have this medication is running at this many mLs per hour. What does that equate to in terms of how much they're getting per hour or per minute and per microgram? So the answer obviously is right here, but we're going to get rid of that and we're going to work it out, okay? So this is what we're going to do. The first thing we do for dimensional analysis, okay, is this. We want to always start with this guy right here. We want to start with either what it's running at right now, or the desired order from the physician. So let's make that work. So the first step we do is we go 23 mLs per hour, and then we want to do we want to usually do the what did the pharmacy send up? So what is it writing? And so we have the bag has 50 milligrams of nitro in 250 mLs. But the question's asking us at the end, how many micrograms per kilogram per minute? And so to eliminate a step, we're not going to do the 50 micrograms over 250 mLs and then do the next to it, do the 1 milligram equals 1,000 micrograms in the next step. So we'll just do this. We'll do, instead of saying 50 milligrams in 250 mLs, we're going to say 50,000 mics in 250 mLs. Okay. And then it wants to know what they're getting in minutes, right? So right now we have it running at mLs per hour. So let's change that to, we already have hours over here. So let's go in 1 hour. We have to put it up top here because we have to eliminate it, and we can only cross cancel across the line here. We can't be on the same the same line down here is what I mean. So in 1 hour, we have how many minutes? We have 60 minutes. Okay. And they already give us the kilograms, but we're going to add this in it because the question is asking how many mics per kilo per minute. So we're going to have to put it down here, 67 kilograms. And we'll just do the 1 over that. All right. So if we work that out using our calculator, we're going to get that's 23 mLs times 50,000 mics times 1 equals 1,150,000. So let's put that over here. So that's 1,150,000. Okay. And what do I mean? What do we have? 1,150,000. Well, let's start eliminating our units. So we can get rid of mLs like that. We can get rid of hours like that. That'll leave us, if we get rid of all that, we have micrograms, kilograms, minutes. Okay? So this up top is micrograms. So this is 1,150,000 micrograms. Okay? Over, and now we're going to times the bottom half of this equation here, which is 250 times 60 times 67. Let's do that. That is 250 times 60 minutes times 67 kilos equals 1,005,000. Okay, so let's do that. 1,005,000. And what do we have at the bottom? That's kilograms per minute down at the bottom. All right. So if we take 1,150,000 and divide it by 1,005,000, we will get so 1,150,000 divided by 1,005,000, we'll get 1.144278606965174. Or we're going to go to the tenths, which is right here, and we're going to look at the number next to it in the hundredths column, and we're going to, is it 5 or more? If it is, we round up. If it's 4 or less, we just leave it the same. So it'll be 1.1. All right, so let's do that here. We got that all equals, or we'll say equals 1.1 mics per kilo per minute. All right. So there's another way to do this. Okay. So it's called reverse engineering. So reverse engineering or base concentration. Okay. Oops. Let me do this real quick. Reverse engineering or base concentration. Okay. All right. So in order to do this you always, in order to do a base concentration or reverse engineering, in order to know what this is, this means nothing to us. This means basically this medication is running on the pump at this, at this many mLs per hour. But realistically, as nurses, that means nothing to us because we don't know, exactly how much medication that patient is receiving, right? And in fact, this question is asking us how many micrograms per kilogram per minute. So this is what we're going to do. We are going to first of all take note of this, but really what we're going to concentrate is on this. What the pharmacy brought up to us or whatever the Pyxis had available. And what it has available is 50 milligrams of nitro in 250 mLs of solution. So once we get a base concentration, we can figure out what 23 mLs equates to in terms of medication. Because we'll break it down. When I say base concentration, I mean how much medicine is in 1 ml of solution. So 1 ml of solution will equal whatever, we just want to know how much medication is in that 1 ml. So in order to do that, we're going to say, again, we're going to take the, amount of medication, with anticipating that we're going to convert it to micrograms because that's what the, question wants us to do. So we'll say, instead of 50, we're going to say 50,000 mics of nitro, right? And we're going to divide it by 250 mLs of solution, okay? So we can figure out what's in each ml, okay? And we'll get our base concentration that way. So that gives us a base concentration of so that's 50,000 divided by 250 mLs. That's 200 mics. That'll equate to 200 mics per 1 ml, okay? That's a base concentration of 200 micrograms per 1 ml. Now, again, if you're all about dimensional analysis, skip this part. This is for the other thinkers that, are saying, well, I never learned dimensional analysis, so I don't really know what to do with this information. So, this is for you guys. This is the way I used to do it because I didn't learn dimensional analysis through school, so I always had to do it this like longhand way or reverse engineering. Alright, so what we're going to do is we're just going to go like this, get rid of all this, knowing that it's 200 mics per 1 ml, okay? And we'll put that over here. 200 mics per 1 ml, okay? And that's just off to the side, so we know base concentration, okay? Alright, so now what we do is we say, if per 1 ml there's 200 mics, then we know that we just have to times 200 mics times 23, because, there's 23 mLs, and we know each ml is worth 200 mics of medicine. So we'll just do that real quick, okay? So we're going to go 200 micrograms per 1 ml times 23 mLs per hour. Sorry. And then that'll give us 4,600 mics per hour. So that's what the patient is receiving currently. All right? So that's what 23 mLs is, 23 mLs per hour. That's what that patient is receiving. So now we want to know what they're getting per minute. So that's that's even easier. All we'll have to do is take this and divide it by 60 minutes. So we take, let's get rid of all this stuff here. So that's 4,600 micrograms per hour divided in, we're going to divide it by 60, okay? 60 minutes, or because we know in 1 hour there's 60 minutes. And that'll equate to, if we crunch the numbers, 76.7 mics micrograms per minute. But then the question asks us further, how many mics per kilo per minute? So now we have to divide this by 67 kilos. So we'll take 76.7 micrograms per minute, and we're going to divide it by his weight, which is 67 kilos, and that'll give us 1.144776119, or 1.14, or 1.1 after we've rounded to the nearest tenth. Same thing. All right. Now let's go ahead and tackle question number 2 with the same method, okay? So the second question says, the nurse receives an order for procainamide at 3 milligrams per minute. The patient weighs 58 kilos. The pharmacy has mixed 2 grams of procainamide in 500 mLs of solution. What is the infusion rate? So let's see what we can do here. Let's use, again, let's use dimensional analysis first. All right. So dimensional analysis is, and what do we start with? We always start with what's going on right now. What is it running at, or what is the order? So right now, the order is to run procainamide at 3 milligrams per minute. So we're going to put that down first, okay? 3 milligrams per minute. And at the end, it wants us to know if we want that, what is, and we get, the pharmacist sends us up this, what are we going to set the pump at that, okay? So at the end, it has to be in mLs per hour. So we got 3 milligrams per minute. The next step is always to, do the concentration of what the pharmacist sends up, and again that's 2 grams in 500 mLs, okay? And but the order is for 3 milligrams, and the pharmacist sends it up to us in grams. So let's convert that. So in 2 grams, we just bring the decimal point over 3 spaces to get 2,000. So 2 grams is 2,000 milligrams. So let's do that, okay? So if we do a line right here to set that up, we know we can't put the milligrams up here. It has to be down here so we can cross-cancel those units, right? So let's put that down right away. So again, this is 2 grams or 2,000 milligrams. We skip that step. All right. So up here, we have to put the 500 mLs because it's 2 grams or 2,000 milligrams of medicine in 500 mLs. So we have to put the 500 mLs up top here. All right. Now, if we get rid of milligrams, this will give us mLs per minute. But the question's asking us how many mLs per hour are we going to run the pump to get this order executed, right? So we have to get rid of minutes and create hours. So we know that there's 60 minutes, which we got to put up here, right? If we made a line here, we're going to do 60 minutes in 1 hour. And that'll take care of it for us. Now, something to notate, you're scratching your head wondering, what do I do with the patient weight over here, right? Why did they even mention it? Well, there's no mention of weight base here in the order, and there's no mention of weight base here in the how they want the question answered. So in this case, it's superfluous. It's not necessary. It's extra information. And the author of this problem put it in just to throw you off. So be careful with this. You got to know when you need it. And there's no mention of needing it in the order or in the how they want the question answered. Well, in the previous one, in question number 1, they want to know how many micrograms per kilogram per minute. So obviously we have to know that information. But right now we have everything we need to come up with this this answer here. So let's crunch this number real quick. We'll pull up our calculator. Oops, let's do this. So we have 3 times 500 times 60 equals 90,000. And what do we have 90,000 of? We have 90,000. And let's cross cancel these things. We should have done this first, but minutes and minutes, milligrams and milligrams. So at the end we have mLs per hour. So up top here we have mLs. And then we just times, there's nothing to times 2,000 with except for 1, so we know that's going to be 2,000 hours. Which equates to, so 90,000 divided by 2,000 equals 45. So that would give us 45 mLs per hour. Okay? All right. So hopefully you this is becoming more familiar as we're going through the second one here. Again, watch this guy because that stuff's superfluous there. Okay. So let's get rid of all this real quick. And now we're going to do base concentration for those that don't want dimensional analysis. For those of you that do dimensional analysis, skip through this part, okay? And we're going to do the base concentration or reverse engineering method, okay? So again, what do we always start with base concentration or reverse engineering? We want to break down this. What is the base concentration based on what the pharmacy gave us? And then, of course, the order is for 3 milligrams per minute, so we got to figure out right away what this is in terms of milligrams. So we know that that's 2,000 milligrams. 2 grams is equivalent to 2,000 milligrams of medicine, right? All right, so we're going to do 2,000 milligrams divided by a solution quantity, which is 500 mLs. Gives us a base concentration of 2000 divided by 500 equals 4. That is 4 milligrams per ml, okay? So in each 1 milliliter, there's 4 milligrams of medicine. All right, now that's important to notate. So we're going to have 4 milligrams in 1 ml for base concentration. We'll just put it up here. Base concentration. All right. Now that we have that information, it'll make sense. It'll make sense to plug it in because it'll mean more. This will mean more. 3 milligrams per minute. So, what's 3 milligrams per minute in terms of mLs? How many mLs is that? All right. We already know that 1 ml is 4 milligrams. So 4 milligrams is more than 3 milligrams, so it's less than 1 ml. Okay, so that should help you make sense. So make sense out of this information. So we're going to do the 3 milligrams. Okay, and divide it by oh, sorry, here we go. 3 milligrams per minute, and then we're going to do 4 milligrams per ml. Okay, so let's go ahead and get rid of this guy. Alright, and this will give us how many mLs we're having per minute now. So 3 divided by 4 equals 0.75, I'm sure, but let's just crunch the numbers. 3 divided by 4 equals 0.75. All right, 0.75 mLs per minute. All right, but the question is asking us, what are we going to set the infusion rate per hour? All right, so you know that there's 60 minutes in 1 hour, so you're just going to times this times 60, right? So times 60 minutes equals 45 mLs per hour. So that's how you do the reverse engineering or base concentration. So it's kind of a longhand way, but to be honest with you, I do it both ways to ensure that I get the same number. And because the reverse engineering here, it actually makes sense to me because I'm not just plugging in numbers, because really, if you plug it in wrong or you start wrong with the dimensional analysis, you can come up with a different answer. So what I like to do is I like to do this because it makes sense to me when I think about, I can visualize, like, you know, just like when I was talking about 4 milligrams per 1 ml. Well, I know if I was to equate, 4 milligrams to 1 ml and just kind of give myself some imagery in terms of what does 3 milligrams mean in terms of mLs. Well, I know it's got to mean less than 1 ml because 4 milligrams is 1 ml and this is 3 milligrams, so it's got to be less than 1 ml. So if I switch these around and had 4 milligrams divided by 3, I'd get a completely different answer and it'd throw off my answer. So yeah, just base concentration reverse engineering means a lot to me. So I typically, to check my own math, do both methods to ensure that I come out with the right answer. All right. So let's move on to number 3 here. So number 3 asks us, it states the patient weighs 117 pounds. Dopamine is running at 30 mLs per hour. There is 400 milligrams of dopamine in 500 mLs of solution. How much dopamine is the patient receiving in micrograms per kilogram per minute? So in this, I want to ask you guys, or I want you guys to think, first of all, is the weight relevant to this answer or to this equation? And it obviously is because it asks for micrograms per kilogram per minute. So in that instance, we gotta convert our pounds to kilograms right away. And then it's asking us, you know, how many micrograms per kilogram. So the pharmacy obviously sent up 400 milligrams of dopamine, 500 ml. So right away, I'm going to convert that to 400,000 mics, because I'm just going to, you know, the decimal would be here, and I'd bring it over 1, 2, 3 more to convert milligrams to micrograms. So that would be 400,000 mics in 500 mLs. So this is much like question 1, but we'll just go through it to make sure that you got it down. Okay, so we'll use the 2 methods again. First method, of course, is... Oops. First method is, you guessed it, dimensional analysis, right? Alright, so what do we start with, guys? You guessed it, good job. You're on it, doggone it. We start with what's going on right now. What's it running at? Or the order that the physician orders, right? But right now we have what it's running at. So let's do that, okay? So right now we have, oh, you know what? First, let's do this. Let's convert the 117 pounds to kilograms. So that's just to kind of keep off in the distance and keep that floating around, so we can plug it in just a second here. But 117 pounds times, divided by 2.2 will give us kilograms. So we'll do that. We'll crunch those numbers real quick. Oops. That's 117 divided by 2.2 equals. And here, remember that on weight is you know, you want to wait to round till the end. However, for the weight, you do it at the beginning. So go to the tenths, right? Round to the nearest tenths. It's 53.181818. So it's really 53.18 with a little line over it, meaning it goes on forever like that. So we'll go to the tenths column here. Look at the look at the hundreds column, and if it's 5 or more, we round this up. So in this instance, the weight will be 53.2 kilos. Okay, so we'll go weight 53.2 kilograms. That's how much the patient weighs. Okay, so that makes more sense here. Now let's start dimensional analysis. So we have 30 mLs per hour. That's what we're starting with, because we always start dimensional analysis with what's running or what's ordered, right? Okay. And then we go next. A good habit to get into is state what the pharmacy gave us, and based on how we set up this, or how we lay this out, which is just reading it right off the question, 30 mLs per hour here, we're gonna have to fashion the other stuff. Okay, so we got mLs up top, so when I do a little line here, I'm gonna do mLs down here, right? Because this mLs is up here. So in order to cross cancel, it has to be down here. So I'll go ahead and put 500 mLs down here. And I will put 400,000 mics, or 400 milligrams. But to eliminate the next step, I'm just going to say 400,000 mics. Okay. All right. And they want it in minutes, right? So we got to get rid of the hours. So in 1 hour, and I'm putting hours up top here because there's hours down here. So I got to be able to cross cancel here and here. So in order to do that, in 1 hour, there's 60 minutes. And then it always asks, kilograms per minute. So I'm actually going to always put the kilograms on the bottom down here. So I'll just go like this. 53.2 kilos. oops, sorry guys, kilograms, 1 over that, okay? So what does this equate to? So when I crunch the numbers, we're going to get 12 million mics. Okay, so I'm just going to put 12 million, and you guys can do the math so you can verify that. 12 million mics, and why do I know that? Because I'm going to get rid of mLs here, get rid of hours here, so that'll leave me mics per kilo per minute. Okay, so micrograms up top, and at the bottom we'll have 1,596,000 minutes. So 1,596,000 kilogram per minute. Now what does that equate to once I divide that? 12 million by 1,596,000. That'll give us, let me just make some room for myself, so take a snapshot with your eyes real quick. That will give us 7.51879. 7.51879. But again, we're going to round to the tenths. So that'll give us 7.5 mics per kilo per minute. Alright, so that's the answer you should have got. Now for the fun reverse engineering, again, dimensional analysis, folks. Fast forward, cover your ears, cover your eyes, etc. This is for the other side of the tracks, which includes me. Alright, so what do we do when we do reverse engineering? Base concentration, right? We're going to find the base concentration again, just based on what the pharmacist gave us, okay? So the answer needs to be in micrograms per kilogram per minute. They send us up a bag with 400 mgs. So let's change that right away to 400,000 micrograms in 500 mLs. So when we divide that there, we get 400,000 divided by 500 mLs. That's 800 mics. That's 800 micrograms per ml base concentration. Okay, so 800 mics, remember that. We'll write that real quick right here. 800 micrograms per 1 ml base concentration. Alright, so now, since we have that, that's step number 1 always. That's always step number 1 of reverse engineering. The second step, or the next thing to do, is to say, figure out what this is first per you know, how much medication is in this 30 mLs, now that we know that each 1 ml is 800, so we can just go 30 times 800 and whatever that is, and then divide it by 60 because we get to get the minutes, and then divide it by 53.2. So let's do that, okay? So we're gonna go 800 times 30, right? Because that's our base concentration, 800 mics per 1 ml times 30 mLs per hour equals, so what's 800 times 30? We'll just go, oops. That's 24,000. Okay. That patient is getting 24,000 mics per hour. Alright, now let's divide that by 60 minutes to see what they're getting per minute. That's 400 mics per minute. Okay. And let's divide that by 53.2 kilos. To get 7.5187 or 7.5 7.5 mics per kilo per minute, just like we did in dimensional analysis. Sound good? You guys getting this down? Those reverse engineering minds, those base concentration minds, and those dimensional analysis minds should be eating this up, getting it down. This is again the black belt of dosage and calc. There will be on the dosage and calc exam some, I'm giving you so much medication, like 1 gram of Rosefin and 50 mLs of normal saline. I want you to run it in 15 minutes. Our physician orders it to be ran in 15 minutes. Rate of administration states 15 minutes, etc. You got to figure out that. That's the old stuff. The drop factor of giving you this much solution, and the drop factor is this. How many drops are they receiving per minute, etc. Those kind of things. But we're ramping up a little bit with this stuff. So brush off that old stuff, do some problems with that. And then let's go over one more, because there's a subtle variation to this. The variation is with number 8, where they say the order's 3 mics per kilo per minute. So the order, the physician writes that order, and this is what you see, and then the pharmacy supplies you with this. What do I set the rate at? In all honesty, this stuff, it has smart formularies, especially when it gets this complex. However, your mind should be able to do this. Okay, if something goes wrong, the generators go out, and you gotta be able to do these kind of things. You gotta be able to program these things, or the smart formulary gets wiped out of your Alaris or Braun pumps or whatever, and you need to think for yourself. So again, the physician, Dr. Martinez or Dr. Yan is going to say, hey, go ahead and order dopamine, at 3 mics per kilo per minute. You've already weighed the patient and converted his pounds to kilogram, and he weighs 73 kilos. Pharmacy sends you up the dopamine, and it's mixed in 400 milligrams in 250 mLs. Right away, you're going to say, okay, the order's for micrograms. So right away, my brain has to say, this 400 micrograms is really 400,000, because here's the decimal. 1, 2, 3 places, 400,000 micrograms in 250 mLs. So how do we start the dimensional analysis here? How do we start the dimensional analysis when there's no rate in mLs going yet? There's if I say I told you step one is always with dimensional analysis to start with what the pump is going at or the order. So in this instance, it's the order. But how do we, when there's three different things here, how do we start that out? This is how we do it. So we do, for the dimensional analysis, step one, just go like this. Go. The order is 3 micrograms per kilogram per minute. Just like that. And then you'll go like this, times, in the line here, we'll go with what the pharmacy sent up, and we got to do the 400,000 mics down here because the mics is already up here. Okay, so 400,000 micrograms in how much? 250 mLs of solution. All right. And what is going to be the infusion rate in mLs per hour? Well, we know that there's minutes right here. So we got to go, there's 60 minutes in 1 hour. All right. And that's all. That's all. Oh, and then we got to do kilograms up here times 73 kilos. And I put kilos right there because there's kilos down here, right? And we'll just do 73 kilos over 1 in this instance, okay? All right, now if we crunch these numbers, we're gonna get. Oh, first of all, let's do this. This is the fun part, right? Isn't it always fun to go micrograms, micrograms, kilograms, kilograms, minutes, minutes. So all we'll have left is mLs per hour. Okay, so let's crunch this. This is 3 times 250 times 60 times 73. So we got 3 times 250 times 60 times 73 equals 3,285,000. 3,285,000. And what do we got there? mLs over 400,000 times 1 times 1 is still 400,000 hours. So let's go ahead and crunch that to see what we get. 3,285,000 divided by 400 equals 8.2125, and we'll go to the tenths, and it's a 1 in the hundreds column, so it's going to stay at 8.2 mLs, okay, per hour. Sound good? Alright guys, let's do this last thing for reverse engineering base concentration, okay? This last little exercise, and we'll call it a night. Base concentration or reverse engineering. Alright, so what do we always start with when we do reverse engineering? What the pharmacy sends up. We know that we need this in micrograms first of all to get the base concentration, because this is the microgram. The order is in micrograms. So that is 400,000 mics divided by 250 mLs gives us a base concentration of, so 400,000 divided by 250 mLs. That's 1,600 mics per ml. So in each 1 ml, there is 1,600 mics. 1,600 micrograms per 1 ml. Okay, that means every 1 milliliter contains this much med. Okay, so now really we can just go like this. This is kind of easy, is we can just go through, let's see. So we're gonna do this. Let's get what the order wants first of all. Okay. So let's do this time. Let's get what the order wants, which is 3 mics per kilo per minute, because we can actually make an equation out of that. So that's 3 mics times 73 kilos times 60 minutes, because we want to know what it is in mLs per hour. All right. So that is 3 times 73 times 60. So 3 times 73 times 60. Okay, that's 3 micrograms, kilograms, minutes. So that'll be how much micrograms there'll be. This will give us how much micrograms they're getting per hour, right? So let's crunch that. 3 times 73 times 60. 3 times 73 times 60 equals 13,140 mics per hour. So 140 micrograms per hour. So now we know, we just have to know, what does this mean in terms of mLs now that we know that the base concentration is this. Okay, so all we're going to do is take this and divide it by 1,600 micrograms per ml, and that'll give us mLs per hour. 13,140 divided by 1,600. What do you know? 8.2. mLs per hour. You guys are like or not like? Alright, I hope you guys enjoyed this. I hope that it wasn't too boring. Math is never that exciting. However, it's a little fun when you apply these different methods. And this is the highest level that you're going to be required to show competency in regards to this dosage and calculation. So work these out utilizing the methods that I've shown you. And I hope this helps. Thank you so much.